A teacher pedagogical tone. Demonstrations. Proof demonstration is a structured argument that follows a sequence of logical steps using theorems to prove an argument. In mathematics, a proof is a series of logical steps to prove an argument. Its function is therefore to prove a mathematical argument or hypothesis using logic. Once the hypothesis has been proven, it becomes a theorem. An example of a theorem is the fact that an even number squared gives an even number. How to construct a mathematical proof? The key elements when writing a mathematical demonstration are: write down any information that is being used. Make sure each step follows a logical sequence. If the proof applies to any integer and a proof only works for odd numbers, it must be demonstrated that it also works for even numbers so that it is valid for all integers. End your demonstration with a statement. Types of demonstrations. Demonstration by deduction. It involves the use of facts or theorems and follows a logical sequence of steps that show the reasoning used to reach the conclusion that proves the conjecture. Example: Argument A, yes, today is the weekend, gives two possible answers, Saturday or Sunday, as these are the two possible days for the statement to be true. On the other hand, you have argument B, so tomorrow will be a weekday. Using the possible answers from arguments A and B to test the logic of the main argument. If today is Saturday, tomorrow is Sunday. Since Sunday is still the weekend, this makes the argument false. On the other hand, if it were Sunday, the argument would be true. Proof by counterexample. It is an example where the hypothesis is not true and therefore does not apply. Sustains. Example: prove that the following is not true. The sum of the square of two integers is always a number that is the result of squaring another integer. A counterexample can be found. To do this, you need to find a single example that does not prove the hypothesis, that it is false. In this case, two squared numbers are required that, when added together, result in a number that is not the result of squaring two numbers. You can try 4 and 9. 4 is 2, 9 is 3. 2 squared plus 3 squared equals 13. That is not a number resulting from the squaring of any integer. This means that the hypothesis we started from is not true. Demonstration by cases. It consists of examining each possible case and checking each one separately. Example: prove that the sum of two consecutive squared integers whose square is between 1 and 81 is an odd number. The numbers resulting from squaring an integer between 1 and 81 are 4, 9, 16, 25, 36, 49, 64. Using case proof. It can be seen that all the numbers added together result in an odd number, which is why the hypothesis we were trying to prove is true. Proof by contradiction. In this case, to prove that something is true, you must first assume the opposite, so it should be false, and with that, try to prove that it is false. Example: prove that there do not exist two integers a and b for which it is true that 5a plus 10b equals 1. Assuming the opposite. It is assumed that there are two integers that satisfy the equation. If they are integers, then the result of a plus 2b must also be whole. Therefore, we have a contradiction, which makes our statement false. Since the opposite has been proven, then the original statement is true. Therefore, the statement, there are no two integers a and b for which 5a plus 10b equals is true.